Hi, welcome to Working with Multidimensional Scientific Data session. This is Nawajish Noman with my colleague Sharmishta Chatterjee from Esri, Redlands, California. Today, we'll talk about scientific multidimensional data in ArcGIS and what's our vision, what are the things you can do with it. Then we'll talk about how could you read, manage, visualize, and explore multidimensional data. Then one of our favorite topic is analysis. So we'll see how you can perform analysis with this data. And if out of the box tools and functions are not adequate for your analysis, how can you extend the analytical capability using Python? Then we'll talk about how could you share all the data that you have prepared and the new information or the data that you have created with broader user community or within your organization for your colleagues. Then we'll point you to some resources for further study. So let's talk about scientific multidimensional data in ArcGIS and what does it mean to us. What do we mean by scientific multidimensional data? This data changes over time or over depth or any other dimension. Some of the examples of this data are observed data from monitoring stations and other platforms. It could be remotely sensed data. Some of this data are observed and then reconstructed using statistical method to fill in the gaps. So we call it reconstructed data. Some of these data are coming out of the simulation model. So these are also multidimensional data, but these are simulation model results or model results. Some of the example of this data in the ocean could be sea surface temperature, salinity, ocean current, etc. In weather, it could be temperature, humidity, wind speed. On land, it could be soil moisture, NDVI, or land cover. This data usually available in netCDF, GRIB, or HDF format. In Esri, we also have multidimensional data format, which is like Mosaic dataset, and cloud raster format through which we can manage this data. So what is our vision? Our vision with this data is very simple. We want to do with this data whatever we do with any other geospatial data, which includes read it directly, manage them, visualize and explore, analyze, and then finally share, and then this cycle continues. So before we move forward, let's take a closer look at multidimensional raster. This is a raster where it has temporal and vertical dimensions, which means it could change over time or it could change over depth or both, which means it becomes a cube or hypercube where each axis are the different side of the cube, right? Now, this cube can have like one variable, or these cubes can represent multiple variables. So in a multidimensional data set, you can actually have more than one variable, more than one cubes. These cubes, as I said, has more than spatial dimensions. They have time or depth. And if you actually take out each slice from this cube, they are nothing but a two-dimensional array. So as the picture, you can see that if I take out a first slice, it may represent time step 1, and the second slice may represent time steps 2, and the third one represent time step 3, so on and so forth. Now, as I said earlier, that these data are represented in a Mosaic dataset or in other raster dataset format like CRF. When we read this data in ArcGIS, we prefer to read data that follows CF convention because that is our kind of the roadmap to understand the data. What is CF convention? It is a climate and forecast convention initially developed for climate and forecast data. Most of the atmosphere or surface or ocean model generated data follow CF convention. Also, observational dataset follow CF convention. Why CF? Because it has a very rich coordinate system handling. So you can specify your coordinate and we can read it and work with other geospatial data. Current version is 1.8. Now if you are not sure if your data or file is CF compliant, you can also use some utility checker to see if it is meeting the stack convention or not. So let's move and see how can we read, manage and explore this data in ArcGIS. Working with multidimensional data in ArcGIS Pro has improved over time and now it has a much better rich environment. You have the option from Add Data to open up a dialog and read dataset, multidimensional dataset there. All the analytical tools or read tools or write tools or data management tools are available in multiple toolbox. The primary one that you might be working with is multidimension tools, where you have the tools for reading the data, tools for writing the data and other data management. In image analyst toolbox and spatial analyst toolbox, you have analytical tools. You can find them in multidimensional analysis toolset. The Pro 2.5 also has a new ribbon to work with multidimensional data, and obviously it calls multidimensional, and it gets activated when you are working with a multidimensional layer. We'll talk about that later in a minute. So how do you read scientific data in ArcGIS? You can directly read netCDF, HDF and GRIB file using the multidimensional raster layer option from Add Data, which brings up Add Multidimensional Raster Layer dialog, where you can specify the file, select the variable, and then you can read it directly. You also have other make tools in multidimensional tools. One of the new one is Make Multidimensional Raster Layer, and we recommend you use this tool to read netCDF, GRIB and HDF. But you also have Make netCDF Raster Layer tool and Make netCDF Feature Layer and Table View tool to read raster from netCDF file or discrete geometries or table. You can also read OpenDepth service using Make OpenDepth Raster Layer tool. You can specify a subsetting and it will create a dynamic multidimensional raster layer. All this format, netCDF, HDF and GRIB, are supported in Mosaic dataset, and we'll talk about that later, how you can leverage Mosaic dataset to read this data as well. Let's take a closer look at the multidimensional ribbon in ArcGIS Pro. In ArcGIS Pro, in this new ribbon, you can do many things. First of all, if you want to look at your data and slice by slice, you can actually select a variable and change the slice and look at them. You can also animate over slide. So you can use the ribbon directly, or you can animate using time slider or range slider. You also have tools to explore the data, such as temporal profile and summary statistics. If you want to do data management, there are tools for that too. You just have to click the drop down and select the tool that you need. There is an analytical tool gallery from where you can actually open the analytical tool that I mentioned earlier from Image Analyst Toolbox or Spatial Analyst Toolbox. There is also an area where you can actually select a variable and then specify your start time and end time, or start depth and end depth, this subset for analysis. So as you can see, this ribbon gave you control and ability to do many things that you may want to do with multidimensional raster. Now that you know how to read and actually explore, let's talk about something else. More often than not, you may have to work with many netCDF files. They are covering different regions, or they are representing different slices in a cube, time step, or depth. Now, when all these files are separate, how do you actually work with them and get a seamless picture or a cube that you're looking for? There, Mosaic dataset come into the picture. It creates a seamless multidimensional cube from different dataset and performs spatial or temporal aggregation, or any dimensional aggregation for that matter. The file could represent different regions, the file could represent different time steps or depth slices or altitude, something similar. Now, what is a Mosaic dataset? It actually a container that point to the file and give you a dynamic mosaic of all the images that you're looking at. It supports multiple files and variables. It also normalizes time and depth. That is very important if you're working with different data set. It gives you a table of records, lives in a geodatabase, and it itself is a raster dataset. It supports on-the-fly analysis, and you can also share the data as service. Working with Mosaic involves two steps. One, first you create the Mosaic dataset, and then, of course, you add raster to it. What about visualizing all this data? You can slice this data through multidimensional ribbon, as I spoke earlier, where you can select the times variable and then choose the time you want to see. You can also select by dimension, use select by dimension tool and change it. And this is very useful when you are performing analysis. You can also change the slice from the layer property dialog in ArcMap. Of course, you have temporal animation purpose. You can use time slider, or you can use range slider if you want to animate through depth or altitude or any non-time dimension. If you want to look at data in a specific order or visualize it by combining this information together, such as wind speed or current, you can actually use predefined renderer like vector field renderer, where all these variables are combined on the fly to represent the information you're looking at. You can also add a custom scientific color scheme to your ArcGIS Pro project. You can also explore the data. You don't have to just stop looking at it. After you look at it, you can actually dig deep, and you can use temporal profile to visualize the distribution of a variable over time. You can also compute summary statistics of a variable to understand about the value that you are working with. This is not the only way you can explore the data. You can also take a closer look at the data through Raster Object in Python. Raster Object is something that represents your entire raster, whether it's a 2D raster, multidimensional raster, or a multi-band raster. You create it from a raster dataset, you get a raster object from an expression, or you can create an empty raster object pointing to an empty raster. It has a bunch of properties, and some of them are dedicated to multidimensional raster. It has lots of good methods, and again, some of them are primarily geared towards multidimensional raster. Now take a close look at them. The properties empty info tells you everything you need to know about the multidimensional raster. It also have other properties like variable names and variables and slices. Methods are grouped into two categories. One group is representing your variable, and the other group to work with dimension. You can see that through these properties and methods, you can actually find out a lot about your data and actually extract the information and the slice you need to work with. With that, I will hand over to Sharmishta so that she can show you how easy it is to read, manage, or visualize this data in ArcGIS.
Thank you, Norman. Norman just discussed about reading and managing scientific data. Now let me show you how to do it. Before I get started with multidimensional data, let me give you a quick overview of all multidimensional functionalities in ArcGIS Pro. From the multidimensional toolbox, you can now read, write, and manage multidimensional data. Analytical tools are available in the Image Analyst and Spatial Analyst toolbox. You can find them in the Multidimensional toolset. In Pro, you now have a multidimensional ribbon to work with multidimensional layers. You can do different things with it. For example, you can visualize a multidimensional raster slice by slice, or can animate through it. You can also use the interactive tools to explore a data using temporal profile and summary statistics. From here, you can also open or invoke data management and analytical tools. These tools are same as available from the toolbox. In this ribbon, you also have the ability to change the analysis extent. You can specify a variable and then a start and an end time and a start and an end depth. Now I would like to add some multidimensional data. I have a HiCom model output from NOAA and I'm interested in the water temperature variable. Since this is the gridded data, I'll add the data as a raster using the add data option. From this dialog, I can add a netCDF, HDF or GRIB file. I'll select the water temperature variable and this will create the water temperature raster layer for region 1. Another way to add raster layer is through the Make Multidimensional Raster Layer tool. Here I also have the option to select a dimension value if I'm interested to look at a specific slice. From this tool, I'll select region 7 and again I'll select water temperature variable and leave everything as default and run the tool. This will create the water temperature raster layer for region 7. I can also run the same tool from ArcPy in the Python window here or in standalone script. Now we know that not all netCDF files are gridded. Some are irregularly spaced like station or profile data. For example, I have this underwater glider data from NOAA and I'm interested to look at the salinity of the ocean. So I'll use the Make netCDF feature layer tool. Select salinity as a variable and I'll specify my row dimensions to get the values from all the points. As you can see, this is how the glider moved. And from the feature attribute table, I can see how salinity varies. I can also just create a table with salinity values if I'm not interested to see the points using the Make netCDF table view tool. In this tool, I specify the latitude, longitude, and the variable I'm interested in, and also the row dimension. The output is a table with the values. Earlier, to visualize region 1 and region 7 from the HiCom data, I ran the tool twice. So this is not very practical when I'm working with a lot of data and files for different region or time step. So I can manage these files using a Mosaic dataset to create a seamless continuous layer. Creating a Mosaic is a two-step process. First, I create an empty Mosaic dataset and then I add rasters to it. I specify netCDF as my raster type and water temperature is the variable I'm interested in. If I don't specify a variable, the Mosaic will be created with all the variables. Then I specify my netCDF files. I have 2 regions with 3 time steps each. When I'm working with many files or I update it frequently, I automate the process using a Python script. In this script, I'm doing the same thing. I'm first creating a Mosaic and then I'm adding rasters to it. Additionally, if you want to look at some of the data together in a certain way, you can specify a processing template. For example, in this script, I'm specifying a processing template that combines the U and the V component together to create ocean current. If I run the tool and the script, I can create the Mosaic dataset. This is how the water temperature looks, and this is how the water current look. As I said earlier, from this ribbon I can change the time step to see values at different time. I can also look at the slices at different depths or can animate through them. So let's visualize a couple of slices to see how depth changes with how water temperature changes with depth. As you can see, the red color turning blue as we are getting deeper into the ocean, which means the water temperature decreases as the depth increases. You can explore your data by animating using the time slider or the rend slider from the properties pane of the layer. So far we have learned about how to read a gridded variable from a netCDF file to a raster in 3 different ways. Read discrete sampling geometries or points from a netCDF file to a feature or a table. And how to manage multiple netCDF files using a Mosaic dataset and visualize it for further exploration. Over to you, Norman.
Thank you, Sharmishta. It was great to see how easy it is to read this data in ArcGIS Pro and work with it. Now let's switch gear and let's talk about performing analysis. How can you do analysis with this data in ArcGIS? We have hundreds of tools already that works with 2D raster and features. You can use all of them to do your analysis once you actually create a model or automate the process and actually loop through them slice by slice. Now, in your analysis, you may use all this tool to do that kind of job, but you may also want to do some analysis that require looking at the data set altogether. Some of the tools we have created fall into that category, the new tools. And you can find them in Image Analyst Toolbox and Spatial Analyst Toolbox. Those are under Multidimensional Analysis Toolset. We also have hundreds of functions that you can actually use to do the analysis. All this functionality is also available in Python through ArcPy API or ArcGIS API for Python. If you look at the ArcPy API, there are 1300 plus comprehensive tools available. They fall into different categories like location analytics, data management, cartography, 3D analysis, and machine learning. If you look at the center, we're talking about raster analysis and image analysis. Those are very useful to work with multidimensional raster and the relevant data set. You can do all of these using ArcPy. Let's take a closer look at some of the new multidimensional tools that we have created that look at the cube as a whole and do some kind of analysis. The first one, of course, the aggregate multidimensional raster, which is very useful and let you aggregate data the way you want. For example, going from daily to monthly or monthly to yearly, you can do summary statistics, different kind of summary statistics with this tool. Another interesting one would be creating anomaly. Of course, things happens and you want to find out whether it is usual or normal or it is something different than rest of the year or some other time period. Anomaly is a very great important tool to actually do that kind of analysis. You also want to find out the trend. So of course we have generate trend raster tool. Once you have the trend, you may want to predict what's going to happen next and predict using trend raster come to picture to do that kind of analysis. Another interesting tool is find argument statistics. It actually lets you find a phenomenon and tell you when it happened. So it is also a useful tool. We also enhance existing tool to do different kind of analysis. In this particular case, what you want to do is you want to do the same analysis that you do with a 2D raster on a multidimensional raster cube where operation is happening on each slice one by one. So we achieve that goal by adding a new parameter called process as multidimensional in some of the tools that we have enhanced. One of them is sample, where you actually have a bunch of points and you want to extract the value under those points. It's like probing, and sample tool does a great job where you can actually probe through your cube and all the dimension and get the value you need. Zonal statistics is another powerful tool that is used for many different analyses, which also support multidimensional processing. Same with the zonal statistics as table. Sometimes you want to do analysis and create an output on disk. Sometimes you don't. Here is an example. Let's say you have temperature in Kelvin. Only thing you want to do is you want to represent that value in Fahrenheit. You don't have to create a new dataset for that. You can actually do on-the-fly analysis using raster function. Another example would be computing wind chill, where you are combine multiple variables together to create a new information. But to do this, you don't have to create a new dataset. So you can find many raster functions which will let you do this kind of thing. You can combine these functions together in a chain and perform analysis. Of course, it will do on-the-fly analysis so that you don't have to save the dataset. It actually extends your analytical capability immensely. If you want, you can save it as a raster function template to give it to your colleague, friend, or use it for future analysis like any other out-of-the-box function. When you are doing analysis, most often you will find out that you may have to do some other data management, data pre-processing, and so on and so forth. It could happen before you perform analysis, it could happen after you perform analysis, or in anywhere in between. So what are the good way to do this kind of data management, data pre-processing, and also do some analysis with multidimensional raster in ArcPy? There are many great ways you can go about it, and you can actually combine all the analytical tool functions and operator in ArcPy. And when you actually perform a multidimensional map algebra expression analysis, it works on the entire multidimensional raster on all the slices. So the raster algebra become multidimensional at that point. You can also use subset, raster collection, etc. to manage your MD raster. You can use for each and apply this kind of function to actually process each of your slices. You can apply any function, or you can actually apply a function chain so that you can do your custom analysis. You can also control the analytical environment with environment like match multidimensional variable. And Sharmishta will show you later on how to actually use this to do some analysis. Let's take another close look about the raster collection. Raster collection defines the group of input raster, and you can actually use attributes to filter it if you want to, right? When you are creating, you can actually use attribute to create that collection, and eventually use attribute to filter it. It has a bunch of properties and methods. The interesting thing about this method is it's not only let you filter the data, but also let you do some analytical operation like maximum or median, mean. It can also let you do the mosaicing. One of the interesting thing about this method is you have something called map. Through map, you can actually apply any other analytical function to it. So raster collection is actually a very powerful way to manage your data and do some analysis. Now, as I said earlier, there will be a time when out-of-the-box tools are not enough, or the function are not enough. You need something more. And you can actually do the analysis by combining NumPy and ArcPy together, and any other Python package together to do your analysis. So NumPy can be a great way to do custom function and custom tools, right? What is it? What is this NumPy? And you probably know about it, but let me just recap quickly. It supports large multidimensional array, and it has lots of great functionality, mathematical functions, and You can do clustering, you can do filtering, you can do linear algebra, optimization, Fourier transformation, you can do some morphologic operation. So the library has very rich collection of analytical functions and which you can use with NumPy. In ArcGIS, we have given you ways to actually read array from raster or create a raster from arrays. The two functions that are very obvious are raster to NumPy array and NumPy array to raster. The name says it all. However, we also extended our raster object to give you the NumPy array or create a raster from it. The read and write method will let you do that. We did not stop there. We also gave you opportunity to work through a big raster through PixelBlock collection so that you can actually process small area at a time. PixelBlock collection will give you a collection of pixel block, and you can actually loop through or iterate through one pixel block at a time and get NumPy array using getData. Once you have the array, NumPy array, you can actually do whatever analysis you want to do. If you don't want to create a new NumPy array and work with it separately, we give you another way to visit all the raster cell one by one, and that is done using raster cell iterator. That's new in ArcPy SA module, where you can use it to visit cell in Raster Object using row and column index. You can read the cell value, you can write it. You can actually iterate through multiple raster dataset and perform analysis at the same location. You can actually visit neighboring location using a relative index, which is very powerful when you are trying to do focal type of operation, which require looking at your neighboring cells. As I said, it's available through Special Analyst module. It has argument through which you can specify your raster and also do some padding. Many people have created tons of tools, and one of the great example is Marine Geospatial Ecology Tools, or MGET. They have more than 280 tools they have created using ArcPy, Python, and expose them as geoprocessing tool. You can do similar thing to actually do the analysis that you want to do if the tool we deliver in the box are not enough or adequate for your work. With that, I will hand over to Sharmishta to do some multidimensional analysis demo, and you'll see how powerful you can really get when you combine all this tool together to solve a problem.
Alright, let's analyze some multidimensional data. In this example, I would like to see the trend and anomaly of sea surface temperature for the last 30 years, and I'll use ArcPy functionalities in Jupyter Notebook in ArcGIS Pro to do my analysis. First, I'll create a subset from 1990 to 2019. Then I'll do a yearly aggregation. And finally, we'll look at the trend and the anomaly. First, I'll import the IA module to get the analytical tools. These tools are licensed, so I'm checking out the image analyst extension. I'm using the ArcPy environment class to define scratch and current workspace and to override my output. The monthly sea surface temperature data is provided by NOAA. This data is reconstructed from observation data, where the missing data are filled using statistical method. The file I have contains data for 170 years, but I'm interested only in the last 30 years. So I'll create a subset for my data using the subset GP tool and specify the time I'm looking for. Now I want to make sure that my subset contains the time period I'm interested in. So I see that I got the SST variable and it has 360 slices since it is a monthly data for 30 years. To look into this multidimensional data in more details, I can get the MD info property from the Raster Object. The data is mean sea surface temperature in degrees centigrade, and it's a monthly data from 1990 to 2019. Now, instead of looking at the temperature variation on a monthly basis, I want to look at the yearly mean. So I'm aggregating my data using the Aggregate Multidimensional Raster tool to calculate mean, and I'll specify year as the interval. Now I want to see the sea surface temperature trend over the 30 years. I'll use the Generate Train Raster tool and look at a linear trend. Since we selected a linear trend, each pixel represents the linear slope for the trend line. Positive value shows the upward trend in purple and negative value shows a downward trend in green. White areas represent places where no significant trend is observed. The Western Pacific sector close to the continental coast shows a cooling trend and the far-off region gives a warming trend. While this is helpful, I want to look at ocean temperature that is significantly different from its mean. So I'll use the same aggregated data to calculate the difference from the mean using the Generate Anomaly tool. The output shows areas with higher or lower value than the mean sea surface temperature. I can change the time window on the time slider to look at the different time slices. To explore further, I can use the temporal profile on this data. For example, I can see that in the equatorial Pacific sector, 2 years stand out. 1997, 98 and 2015, both of which are El Nino years. To look at the intensity of El Nino in the equatorial Pacific, I can use this El Nino region to calculate the mean anomaly using the zonal statistics as table tool. The output to this tool is a table where I can get the values, the mean values for all the regions for each time slice. This will give me some useful insights to do further analysis with this dataset. Now let's look at another example. I want to compare the growing degree days or GDT between 1980 and 1990. GDT is an indicator of heat accumulation to predict plant and animal development. Here, I first create a multidimensional raster, calculate GDT, and then calculate monthly GDT from it and persist my output. In this section, I'm specifying the image analyst module, the license, and my environment. Now I have daily maximum and daily minimum day mid surface temperature data from 1980 and 1990 from Oak Ridge National Lab. These are 4 separate netCDF files. In order to do the calculation, I'll have to combine the maximum temperature in a single multidimensional raster and the same for the minimum temperature. So when I combine the maximum temperature, I see that I have 730 slices. From MD info, I can get more information that these are daily data and these are for 1980 and 1990. I'll do the same thing for my daily minimum temperature. Now I need to do a slice by slice operation between this two multidimensional raster containing 2 different variables. To ignore the variable name for further calculation, I'll set the match multidimensional variable environment to false. This is a simple map algebraic expression that I'll be working on, but it will be applied to the entire cube. Using base temperature as 10 degrees, I'll calculate the number of growing degree days. Then I'll remap it to represent only the positive values. I'll look at the GDT slice for June 1st and use a slope color map renderer to visualize the difference. To calculate the monthly growing degree days, I'll use the aggregate function to sum the values using month as the interval. Now I'm expecting 24 slices for the 24 months for these 2 years instead of 730 slices for the 730 days from the last 2 years. Here again, I can visualize any given slice and then finally save and persist my data. To visualize further and to compare on the monthly GDT, I can read my output in Pro. I can visualize the changes in GDT from 1980 and 1990 by looking at the slices from the ribbon. To get the monthly GDT values in a table for a given region, say Around Redlands, I can use the sample tool and process it as multidimension. Here I am specifying Redlands as the location, and then this is my output where I can see the monthly GDT and how it varies for each of the month for 1980 and 1990. I can also visualize this in a chart that I can create from the sample output. From the chart, I can compare, say for example, the month of May and look at the difference in GDT between these 2 years. Charts like this help me gain more insights about the monthly accumulated GDT between these 2 years, where all of the analysis is done within the Pro environment using tools and functions from ArcPy. That's how you can extend the analytical capabilities using existing tools, properties, methods, classes, and functions. You can also build your own script tool using ArcPy, SciPy, and many other Python packages. Over to you, Norman.
Thank you, Sharmishta. That was great. You see how much analysis you can do using ArcPy and ArcGIS. Isn't it interesting? So let's talk about something else now. Now that you have done your good work, compiled your data, created new information, how can you share them? Now, ArcGIS platform is a great platform for disseminating or sharing your work. In this architecture or in this platform, as you can see, that you can actually create Mosaic dataset or other dataset, and you can publish them on a server, and you have other services that's coming through as online content and services. Now, as a user, you can actually sit on the other side, and through desktop, through web, or through device, you can actually consume this data and do additional work. So how do you really share the data? It's pretty simple actually. You create your Mosaic dataset and you right click and you say from catalog window, you say share as web layer. When you do that, it gives you a dialog where you can specify all the information, and then in configuration tab you can also check some boxes in case you want to support OGC standards. You can publish map service. It makes maps and make it available to the web. It also supports WMS, and it can be multidimensional WMS. You can also serve a what we call image service, so that your user or somebody can get the pixel value and do some work with it if needed, beyond just looking at it. It also supports WMS. Here's an example of workflow of sharing very high resolution data. It's called hard data. It's a high resolution rapid refresh weather model data, 3 kilometer resolution, hourly update. So as you can see in the workflow that the model is cranking out output, is going to a database, we're downloading, and we are creating Mosaic using all the new data, and then publishing it and serving through ArcGIS image server and updating on a regular basis. So it's a great example how you can not only share your data, but continuously update the content of that service that you are sharing. Now let's talk about how can you consume this data and what do you do with it. You can consume this data in any ArcGIS application or any WMS client. In a web map, you can actually get the map and you can bring other layer into the web map and work with them. You can also share them or consume them in configurable apps, story maps, and web app builder. You can actually build a custom map or custom web app. Here's an example, or many examples indeed, showing you how you can present your actionable information. You can have a industry solutions template, you can have app templates, and using app builder you can create your own apps. You can also have workflow apps. Jupyter Notebook is a great way to disseminate information, and we have hosted notebook. You can use Python API to do that, and Storybook is another great way to do it. So here's an example where somebody created a customizing app operational dashboard where Raster Analytics and Python API was used to monitor coral bleaching, and it shows the alert level and the coral stress over time. We not only asking you to share this data, we are doing it ourselves also. Right, in Living Atlas, if you go, you will see different category, and under environment, you can actually check Earth observation, ocean and weather data, and you can see lots of content there. Some of them are actually apps. An example here is the steam gauge observation, and the another one where you are actually looking at the ice cap. There are great story maps through which you can actually disseminate not only your information or the data, but the analytical procedure, what and write about it, or how to actually interpret the result or understand it. One of the example is tropical cyclone wind exposure in United States. The other one on the other side is the 5 years of drought, which is an important topic. Actually, both of them are very important and relevant topic for what's going on these days. Now, with that, let's focus on what can we do. We can do many things with ArcGIS. As you can see, we can bring in remotely sensed data or scientific data, and we can analyze them. We can actually create a rich information product, and then we can actually disseminate whatever way we want. It could be file. If it is a file, we can choose the format we want. If it is a service, we can actually choose what capability we want to enable. And then we disseminate them through ArcGIS online or on-prem portal. When we do that, your colleagues or broader community, they can discover the data, they can consume it, and then they can also contribute their own data and work into this system. So this platform become a really big collaborative platform for scientific collaboration. With that, I will hand over to Sharmishta again to show you how you can easily share data and consume it.
Thank you, Norman. Now that I have explored some datasets, created new information from my analysis, I would like to share some of the multidimensional data with my colleagues within the organization or outside user group for further analysis. I would like to publish the yearly aggregated mean sea surface temperature data that I created in an earlier example. I'll go ahead and share the data. To do that, I'll need to publish. I'll right-click on the data and share as web layer. To publish, I must have administrator or publisher access. I'll share as a web layer with a name. I'll give a summary and a tag. I'll share it with everyone to make sure internal and external users can access it. From the configuration pane, I'll enable WMS and WCS so that other clients that require OGC standard can consume it. And then I'll publish my data. If I'm responsible for publishing many data from my organization, instead of doing it manually one by one, I would rather automate the process. You can look at this resource in this help page for more information. Now the data is published. This data now shows up as a portal item in my ArcGIS Enterprise server. After adding it to the map, it looks like any other raster layer. I can see it from the property page, however, that it is an image service. Now we can use any geoprocessing tools and raster function that can take image service input and do further analysis on it. I'm interested to look at the 20 degrees centigrade isotherm line along with the anomaly. I can do that by running the contour raster function using the image service layer as input. Let's take a look how the 20 degrees centigrade isotherm changes with anomaly over the last 30 years. The animation clearly shows how region over 20 degrees centigrade varies over time. You can use hundreds of other tools and functions to do many other analyses of your choice. That's how we share and consume multidimensional data for analysis. Over to you, Norman.
Thank you, Sharmishta. It was really great to see how easy it is to solve the data and actually bring it in to do some additional analysis. Now, of course, we don't want you to stop after looking at this demo or the slides. You probably want to go and find out additional information. And we have a wealth of information actually in our system. You can go to ArcGIS imagery workflow to see how some of the problems are solved, and actually you can apply those similar knowledge to do your work. You can also go to LearnGIS and actually look for the lessons or learn path and learn more about it. You can go to ArcPy functionality reference and look at the ArcPy classes, functions, and image analyst module and spatial analyst module to learn more about all the things that we have. You can also go to the geoprocessing tool reference for multidimensional toolbox, image analyst toolbox, or spatial analyst toolbox and learn more about it. Again, you can, as I said, you can go to ArcGIS Learn Lessons and find the lessons you want, or you can also look for different blogs, because we are really excited to communicate about our work through blogs, and our users also do so. So you can actually go to the blog and find out what people are doing with their data and with ArcGIS. So we are at the end of our session, so let us quickly summarize what we have learned. We have learned ArcGIS platform provides a rich set of functionality to work with multidimensional scientific data. You can do a lot with our software at this point. Multidimensional ribbon, new and enhanced tool makes it much easier to visualize, explore, and analyze multidimensional raster. ArcPy Raster Object has taken a new dimension. It now represents the entire raster, and if it is a multidimensional raster, you can actually do a lot of things with it as well. You have seen it in the example, demo, and some of the properties and methods that we have discussed. It represents multidimensional raster very well. Mosaic dataset is a robust data model that allows you to manage your large data collection for scientific multidimensional data. Raster function can help you with your efficient on-the-fly computing, right? You don't have to create data and save it. You can actually do it on the fly. That saves time, that saves resources. ArcPy and NumPy is a very powerful way to extend analytical capabilities using Python. You can create any tool that you want to create. Once you're done with all these things, you can go ahead and share your data or your result as a service. And once you do that, somebody can turn around and consume it in many applications, including further analysis and creation of new information, decision making, etc. So as you can see, ArcGIS has become a great platform for scientific collaboration. With that, I thank you for listening to us. I hope you find it useful and you can have a good time with multidimensional data in ArcGIS. Thank you very much.